Now I'm going to introduce our next panel, and this is a hot topic around the world. It's a keynote speech, actually, and it's called Building Better Apps with Zero Knowledge. So I'm also really excited for this one, and I'd love to welcome our speaker to the stage, Anthony Day from Midnight.
Hello, hello. Guten Tag, guten Abend, Mahlzeit, whichever you guys prefer. Good afternoon. Thank you so much for turning out. Thank you to the conference guys for putting on an incredible venue, incredible setup, incredible talks so far. Very happy to be here after you guys are digesting your lunch and talking, hopefully at an accessible level, about zero knowledge. Very quick straw poll, show of hands if I may. How many in the audience have heard about zero knowledge technology before? All right, that's good, a lot. What I'd like to do today is to present how to think about zero knowledge in the concept of building applications. I think, as the blockchain and Web3 industry tends to do, we talk an awful lot about how the technology works and not what you can actually do with it. And so you probably will have read lots about zero knowledge proofs, about scalability through zero knowledge rollups, but rollups are really just a scaling strategy for the most part. What I'd like to talk about is using zero knowledge for apps, or decentralized apps and dApps. And so I'm going to go through a little bit of a journey around how applications are built at hopefully a relatively high level and simplified view, and demonstrate some examples of why I think everybody in this room should be thinking about zero knowledge and how to build better apps a slightly different way. The main premise of that being, rather than sending sensitive data over the internet, we send proofs of data. Sounds really simple, right? But it really is actually that simple when you come down to the concept of the problem we have today when it comes to data protection, privacy, compliance, is that for the most part, most of the apps we interact with on the internet today require us to send sensitive data about ourselves, our company, our financials, ourselves as an individual, over the internet to a third party. And that's where the problem starts. Data is a challenging thing. It's quite hard to keep hold of. Once you've sent it, it's quite hard to keep track of. And so your data, the data that you submit out into the internet, whether you're an individual or a company, is a bit like a leaky bucket. You keep topping it up and it keeps going to places around the world, and you don't really know exactly where it's gone. And it's quite hard as a result to control. And I'm sure you guys have seen 1,000,001 infographics around how much data is created every minute, whether you're talking about social media, whether you're talking about regular applications, e-commerce, IoT, any of the particular places you can choose to create data and where your sensitive data might be going. That's already a number of different applications that are already challenging the theory of not sending sensitive data. Also, if you look at the future or the next direction of travel with agents, we've already heard plenty today from Dima, from Olga, from others around artificial intelligence, and the role that agents and smart agents will play in proliferating transactions, in acting on behalf of us and our companies. Those are going to be other places where sensitive data is going to leak. And when I say sensitive data, I want everybody in the room to realize that it's not about me, my date of birth, my address. Sensitive data is data around your company, what your personal accounts are, how much produce you ship, right? Where you're based, what you turned in last year, the keys or the wallet address of your particular organization when you transact on chain. Sort of the sensitivity of data is as imperative in a B2B context as it is in B2C. And so a radical simplification, but essentially for most apps that we engage with today, this is how they work. On the left-hand side, you have the user. That could be a business or an individual, or an agent in this case. We send over a secure internet packets of data, and that is received by a receiving party, in this case a company, and that data is typically stored somewhere. Now, I don't want to contest, Dima started to answer the question around quantum, whether the existing computational paradigm is sufficient to protect secure encrypted data over the internet. I don't want to go there, but look into that as well, because secure data sent over the internet today over internet protocols may not be quantum resistant, but that's not the thing that I'm trying to contest. But that's broadly the model that we see today for most applications. And so on the side of the user, or the side of the person who is sending the data, typically we're sharing more data than is necessary. That data may be sensitive and valuable to you as an individual. It may be particularly attractive to third parties who want to commit identity fraud. And for the most part, there is very little equity in when you share your data. There are very many companies out there that have business models that take your data, make you the product, profit from the data that you have given to them, and you have no share or no stake in the overall performance of the company. And that's okay, we're kind of used to that at this point, but that's shifting, or that's changing, or when we look at Web3, we can create win-win-win models where we can actually move that around. And we can change the way that we incentivize users to share data and information, and in an automated way, reward them. That's good for adoption, that's good for uptake, that's good for retention. Anybody who's looking at the commercial drivers for doing that, as opposed to just providing a really good app and hoping that people will submit their sensitive data, right? Web3 allows us different business models to do things differently, and so that's a good thing. At Midnight, one of our fundamental beliefs is that utility shouldn't come at the expense of your sensitive data, whether you are a business or whether you're an individual. And let's not think that all of the organizations on the right-hand side are nefarious either. Many of you, in fact, I'm sure most of you here, run companies or are part of organizations that are on this right-hand side that are capturing, storing, and governing sensitive data. And that's expensive. It's complicated. It requires regulatory compliance. It sucks. If companies didn't have to do this, they would be delighted. And there is a cost of doing business, of architecting your applications this way, that most businesses want to move away from. If you look at the line item for the cost of compliance for most financial services institutions, it's in the multiple millions of dollars, if not the tens of millions of dollars, just because they're managing data. Right? Imagine what you could do from an innovation standpoint if you reallocated that capital to improving customer experience or features on your roadmap. So we need to try and find a way to liberate that data, take it out of the hands of third parties, give more control to the individual, and in about 2009, we came up with a perfect model for doing so: the blockchains. And for the most part, these provided some really good functionalities and features. They're decentralized, so they are very hard to take down. They enable self-custody, the ability for an individual with a wallet or with credentials to control what happens most of the time. They are also censor resistant, so it's really good for preventing hacks, takedowns, etc. Also, blockchains, very, very transparent. And I'll get into more of that in a minute, but a very large amount of your data and metadata, and we'll talk about metadata and the risk of metadata, is visible to everybody on-chain all the time. And that's not necessarily a good thing. Also, when we come to trying to prevent that or trying to work around that, we've seen projects that are focused specifically on privacy for good and in some cases nefarious reasons, like Tornado Cash, lead to, or start with the best of intentions, but lead to a number of developers facing jail time or convictions. And I don't think any of us want to see developers trying to improve the way things are done in the world, having to face jail time because they considered data protection as part of the requirement set. I don't think that's fair at all. And so these are some of the challenges that we have to face around the current implementation of blockchains and at Midnight what we're trying to address. And so this is where we got to with decentralized apps for the most part. And again, a radical oversimplification for the sake of the demonstration. This is not a technical presentation. This is an overview of the domain of importance. We introduced decentralized applications on blockchains. On the left-hand side, we have the user, we have their wallet, we have their credential management, self-custody, all of that good stuff. And in the middle, we have the blockchain component, where we're appending data to blocks so it's transparent and visible to everybody. But at the same time, we're also creating alongside that data about that data. We know it's going to be transparent, but we also have some unintended consequences of putting that data on chain. Also, bonus problem is that actually, oftentimes the way that dApps are constructed, they still use cloud infrastructure, and you're still sharing sensitive data to be able to interact with the company or the third party that you're using the app with. And so you end up still with the same problem at the right-hand side, where because of the way the dApp is architected, you still have a bunch of sensitive customer data sitting requiring to be governed. So we still haven't quite got this right. Back to the transparency of blockchains. And these are two snapshots of wallets. The one on the left is Vitalik Buterin. The one on the right is Justin Sun. This is quite cool. I can look at the current balances in a number of different tokens, the transaction history of the wallets that are known about them. I don't know if they necessarily intended to publish that those were the wallet addresses, but they are. And so now that is information that's in the public domain. However it got there it is in the public domain, and now everybody can go check it out. All right? Hands up anyone in the room who has connected their MetaMask wallets to Facebook or Instagram. Don't do that. Do not put your hand up. But think about it. If you have at any one point, Mark Zuckerberg now has your Facebook and Instagram account and also this. You've basically given him the equivalent of your browsing data and your bank account in one fell swoop. Congratulations, you played yourselves. Not good, generally speaking. And so this is part of the reason why a number of enterprises and large-scale organizations are still struggling with the concept of blockchains, particularly public blockchains, and go down the private DLT route, is that amount of transparency presents a real concern to them. We've got a whole bunch of world-class, large Fortune 500 organizations queuing up in the research, pilot, and in development stage of using public chains, and then they get to the point where somebody in risk says, so how much of our operational data is going to be visible to everybody in the world? And the really enthusiastic young project manager that was in charge of bringing this to the leadership says, all of it, and that's where we hit that red stop sign. Because that amount of transparency scares the living daylights out of large organizations. I said I was going to talk about metadata. Right? And this is an important context, whether you're technical or non-technical, in the context of what a decentralized application is doing or what your wallet is doing on-chain. These are some of the things. And for the most part, when it comes to doing peer-to-peer transactions, this is necessary information. Right? The sender address, the receiver address, the timestamp of when it happened, transaction amount. Chances are you're paying a gas fee to be able to make a transaction on chain, so that's visible when you pay the gas fee from your wallet. The smart contract you interacted with, which is what application are you using, and maybe some extra blobs of data that are appended to that transaction. Right? That feels appropriate, right? If I want to send 1 Bitcoin to anybody in the audience, I'm not going to do hands up, I'm not going to do that either. But if I wanted to, these would be the things that I would expect to see to make sure the system works. Now, think in a business context. If I look at Coca-Cola or any supply chain organization, I'm going to say, right, I can observe, somehow I managed to find out one of the wallet addresses of one of these corporates or one of these enterprises that's using a supply chain system. If I have their sender address, their timestamp, the transaction fee, because gas isn't shielded, and the smart contract they're interacting with, I can start to make certain inferences about what they are doing, how often they're doing it. And there are plenty of YouTube videos about how many transactions it takes for Chainalysis to find out where you live. The same is true of enterprise transactions. So if you start correlating these types of data against a wallet that's known or an account address that's known, you can look at being able to understand production throughput, how busy they are, shipment frequency, delivery routes, carbon output of the organization, a whole bunch of different things that that organization doesn't want you to find out about. It's not directly written in the smart contract. It's not appended on chain, but that is data about data that people with very powerful systems can start correlating to start learning a whole bunch of things about your organization, which generally speaking is not good. Or at least it scares off enterprise adoption. And I think what we're trying to move towards in most cases here is the wider scale adoption of decentralized technology. And if we have these sorts of barriers, we need to move beyond them. And so, an architecture for doing that differently. Data protecting decentralized applications. And so the way we do this at Midnight is we have all of the data set privately with the user, as you might expect, and it never moves. It never leaves. I talked about this before. The intent is to send a proof of data rather than the data itself. What you're then able to do, if you look at those certificates in the middle, is send those proofs to the smart contract, and either, in a fully shielded way, the smart contract responds, saying, okay, this happened. And I'll give you some examples in a minute. And the company on the right-hand side needs to know nothing about you, nothing about your information. It just needs to know that the things it asked of you were completed, and the application proceeds as normal. Right? No data, no sensitive data is stored. The company on the right knows the smart contract has processed whatever it needs to process, and you move on without storing, managing, governing any sensitive data in the process. You can also fully do unshielded. So you can do transactions with the same transparency as Ethereum if you want to. The nice thing about Midnight is that you have full programmability as to which parts of the logic in your application you make shielded and which ones you make unshielded. Now, you could have fully shielded all of the time, but if you have any compliance requirements around how your application works, you may want to make some of it transparent, some of it shielded. And then the bonus point is you can use selective disclosure to expose that data if the user is requested to do so and the user signs that it is able to do so, to then make that further data available afterwards. And that is a very different way of architecting applications to how we often do them today. So the principles that sit behind that. Data always remains with the owner. We have programmable shielding so that if we can't have either on or off, right? We have that today and that's not working. So fully transparent is too transparent. Fully private gets you in jail, or at least would be very hard to convince regulators is compliant. Selective disclosure, and we want to welcome compliance. The second we have technology that is shown or is seen to be avoiding compliance, we get into problems. So we have to embrace that as a concept. Again, the important thing here is we sit behind a fundamental different way of acting and developing apps, which is send proofs of data, not the data itself. So what can you prove? Right? That was a lot of theoretical stuff, but the important bit, and the bit that most zero-knowledge presentations don't get to, is, well, what am I proving? What do I actually get to do with this? Proofs, as an individual, as a company, can be practically anything that you can digitize. It can be a secret, or the fact that you have a document. I have been given this request for proposal. I have it on my hard drive. I can prove to the system that I've been given this document, and therefore I'm able to enter a tender. Really boring procurement example, right? These examples are often very, very dull, but they are often very, very big in scale and potential. A KYC record, a credential of your age, the jurisdiction you live in. Proof of solvency, a lot of discussion around that with exchanges. Proof of integrity of data, that data hasn't been tampered with. Very, very useful in terms of data monetization. Proof of product formulation. Right, this is really interesting. Being able to demonstrate that your product matches the technical criteria that is requested in the specification for manufacturing, or for working with an automaker, or whatever it might be, but without actually revealing the secret recipe of what you actually have created, the intellectual property that sits behind your formulation. So you can be compliant to produce without sharing your sensitive intellectual property with an OEM, and that OEM then giving it to one of their preferred suppliers, and you've lost your competitive advantage. Intellectual property is a massive important area when it comes to working in business to business, and this is an area where proofs can be super important. And system performance as well, proof that you have the computational or the storage capacity, or that you have existing storage still available to be able to allow for automation and compute. And so here we have, take a screenshot of this one if you want to, some of the areas where we see problems being addressed by using proofs of data and not data themselves. We talked about procurement, cookieless e-commerce, the safe operation of decentralized financial institutions, or regular financial institutions for that matter, protection of IP, the scaling of AI and data networks in an automated way, the use of agents, critically important here. So, the benefits to individuals, you get to protect your data. Fundamentally, we can open up new business models, we can reduce the risk of fraud, and we can start introducing the ability to bring your own credentials. Being able to own your identity, credentials, experience, documentation, and use that without sharing it in a sensitive way. Benefits to enterprises is you get to dramatically reduce the cost of compliance and also protect your intellectual property when transacting online. If we want to see enterprises engaging with decentralized apps, we have to protect the intellectual property that they bring with them and make it easy for them to transact. Now, anybody at this point who's not convinced that this is a useful thing, I'm sorry, I tried. But also, think about a few years forwards, zoom out a little bit. Right? If you can't find applications for this now, 5 years from now or 3 years from now, bring it whatever time horizon you want, will we see more or less data in the world than we have today? Will we see more or less automation around applications and data today? Will we see more or less oligopolies trying to centralize that data and control it? And will we have more or less trust in a system that looks like that? And if the answer to any of these is more in your head, the requirement to send proofs and not sensitive data, in my view, in our view, only goes up. And so if you want to learn more about this, if you want to learn more about proofs, if you want to see more examples of using applications using zero-knowledge proofs, come check out Midnight. Happy to talk and take questions after this, because I know I've already run a little bit long. Midnight.network for the website. Check us out on Twitter, midnight.network. There's a Discord as well where you guys can go and engage directly with our developer relations teams and start talking about building actual applications that use proofs. That is the hurdle that we need to get over to start seeing more wide stream adoption. We don't need more protocols, we don't need more infrastructure, we don't need more proving algorithms and systems, we don't need better curves. We just need more people building apps. Thank you.